Welcome back, guys. Today we'll be doing solving a differential equation using Laplace transform. Here we're going to solve y double prime, which means the second derivative, minus 3y prime, where y prime represents the first derivative, plus 2y is equal to 2e to the 3t, where we're given some condition where y0 is equal to 5, and we also have another condition where y prime 0 is equal to 7. Now we are going to solve this by finding the Laplace transform of each individual term. So y double prime, the Laplace transform of this will give us s squared capital Fs minus s times y of 0 minus y prime 0. The Laplace transform of y prime, so I'm going to rewrite the minus 3 first. So we have minus 3, open brackets, s capital Fs minus y of 0. Now find the Laplace transform of y. That will be capital Fs. Now the transform of e to the 3t, so we find the Laplace transform of e to the 3t. It will be 1 over s minus 3, because here the coefficient of t, that's what we're using, so we have 1 over s minus 3. So if it was e to the 2t, then we'd have 1 over s minus 2. So now we're going to clear this bracket that I have. So I'm rewriting this part, and then I have minus y prime 0. Now clearing this, negative 3 times the s times capital Fs will be minus 3s capital Fs. Then negative 3 times minus y0 will be plus 3y0. Then we have plus 2 capital Fs. Then 2 times 1, that would be 2 over s minus 3. Now we're going to group the ones that have capital Fs, but I'm going to do two things, group and factor the capital Fs. So the coefficients I'm going to group together, so I'm going to have s squared, let me go and write my bracket first. So I will have s squared coming from this, minus 3s plus 2. So basically grouping the capital Fs, then factoring out capital Fs. So that's why I have s squared minus 3s plus 2 inside the bracket, because these are the coefficients. Now the remaining, I'm going to carry over the equal sign, what I didn't use, sy0, 3y0, y prime 0. So I have 2 over s minus 3 plus s y0. The minus y prime 0 carried over the equal sign, so it becomes plus y prime 0, then carrying the 3y0 to become minus 3y0. Now we're going to use the condition that I have. So just rewriting the left hand side, then I use y of 0 is 5 and y prime 0 is 7. Equal 2 over s minus 3. Now y of 0, that is 5 based on a condition. So that means this is the same as 5s. Now y prime 0 is 7 and y of 0 is 5. So 5 times 3 will give us 15. Now simplifying this, 7 take away 15. That will give us minus 8. So I am going to replace here with a minus 8. Now we're going to find the LCM. So I have all of this over 1. Then the LCM for s minus 3, 1, and 1 that's in the denominator is s minus 3. Now we're going to say s minus 3 into s minus 3 gives us 1. So 1 times 2 is 2 plus 1 into s minus 3, that gives me s minus 3. So s minus 3 times 5s, so 5s times s, that's 5s squared. And 5s times minus 3, that gives us minus 15s. 1 into s minus 3, that gives us s minus 3. Then multiply minus 8 times s, that's minus 8s. And minus 8 times minus 3, that will be positive 24. Now I can simplify further. Let me just write the 5s squared first. Then minus 15s minus 8s, that is a minus 23s. Then 2 plus 24, that gives us 26. All over s minus 3. Now I will be writing the left hand side, which is s squared minus 3s plus 2 times capital Fs. I'm then going to divide both sides by s squared minus 3s plus 2. So both sides will be divided, so it is on the right hand side, the s squared minus 3s plus 2 will go in the denominator. So on the left, these two cancel. So what am I left with? Capital Fs is equal to all of what I have on the right, which is 5s squared minus 23s plus 26 all over s minus 3 times the s squared minus 3s plus 2. Now, where I have s squared minus 3s plus 2, instead of rewriting it, I'm going to factorize, because this quadratic can be factorized, so we will be factorizing. I need two numbers that multiply to give me positive 2, but add to give me negative 3. That's minus 1 and minus 2. So I replace the center with the factors. So I have minus s and minus 2s. Remember, minus s means minus 1s. Now grouping, I look at the first bracket. What can I factor out? I can factor out an s, and I'm left with s minus 1. In the second bracket, I can factor out a minus 2, and I'm left with s minus 1. So this is s minus 2 and s plus 2. So replacing where I would have my quadratic with s minus 2 and s minus 1. Now we'll be using partial fraction to separate this. So expressing this as a partial fraction, we will have a all over s minus 3 plus b all over s minus 1 plus c all over s minus 2. Now, the LCM for this will be s minus 3 times s minus 1 times s minus 2. Now, we're going to divide s minus 3 into all of what I have here. The s minus 3 cancel, and what I'm left with is s minus 1 times s minus 2, and I multiply by the a in the numerator. Same case, s minus 1 into all of this, it cancels the s minus 1, so multiplying b by what is remaining, I will have s minus 3 times s minus 2 multiplied by the letter b. Finally, s minus 2 into all of what I have here, the s minus 2 cancel. So what I have remaining, I multiply by c. So I have s minus 3 times s minus 1 multiplied by c. Now the left hand side is equivalent to the right hand side, so we equate the numerators to be equal. Now I'm going to substitute values for s to see what can I eliminate to find out what is the value of a, b, and c. Now if I make s to be 1, I can have some cancellation. So let s be equal to 1. So I'm substituting 1. So I'm going to have 5, and then s squared becomes 1 squared minus 23 times 1 plus 26. Now on this side, the right hand side, substituting s equal 1, that will be 1 minus 1, that's 0. So 0 times all of this will be gone, right? Now where I have b, substituting s to be 1, there will not be a 0. So substituting, I'll have 1 minus 3 and 1 minus 2. The next section, replacing s to be 1 here, 1 minus 1 is 0. So 0 times all of this basically will be gone. So all I have is to calculate this side. So 1 squared is 1, and 1 times 5, that's 5 minus 23, because 1 times 23 is 23, plus 26. So adding this, and then 1 minus 3, that's minus 2. 1 minus 1, that's negative 1. Multiplying these two numbers, be positive 2b. So simplifying the left hand side, 5 minus 23 plus 26, that will be 8. Then we divide both sides by 2. So here this cancels, and 2 into 8 goes 4 times, so b is equal to 4. Now I'm going to choose another s value to have some part of this numerator being equated to be 0. So I'll be selecting s to be 2 because 2 minus 2 right here, that will be 0, so all of that will be eliminated. Same case here, 2 minus 2, that will be 0, so all of this section will be eliminated. So I'm just left with c times s minus 3 times s minus 1. Now, substituting 2 into the left hand side, that's what's happening here. So where I see s, I replace it with 2, and on my right hand side, these will be gone. So all I'm left with is c, open bracket, 2 minus 3, close bracket, open bracket, 2 minus 1. So 2 minus 1 is 1, 2 minus 3, that's negative 1. So 1 times minus 1, that's minus 1 or minus c. So minus 1c or minus c. 2 squares 4, and 4 fives 20. 2 times 23, that's 46, plus 26. So 20 minus 46, that's minus 26, plus 26, that's 0. So basically, C is 0 once you're having 0 on the left-hand side. Now, let us look at when s is equal to 3. So when s is equal to 3, we are going to substitute 3 into all of this, but 3 minus 3, that's 0, so all of this will be gone. Same case here, 3 minus 3, that's 0, so everything will be gone there. So therefore, what am I going to have? 5 times 3 squared minus 23 times 3 plus 26 is equal to, substituting 3, we have a, open bracket, 3 take away 1, and 3 minus 2. Now this part I don't have to write because it will be 0, because 3 minus 3, as I've explained, would give us 0 and everything will be eliminated. Now 3 squares 9, and 9 fives 45. 23 times 3, that's 69 plus 26. 3 minus 1, that's 2, and 3 minus 2 is 1, so we have this to be 2a. Now calculating the left hand side, we have 49 minus 69 plus 26, that's 2. So divide both sides by 2, so a is equal to 1. So we found a to be 1, b to be 4, and c to be 0. So we're going to substitute it into the partial fraction that we have. So substituting my a is 1, so I have 1 over s minus 3. My b is 4, so I have 4 over s minus 1. And since c is 0, we don't have to rewrite this because that will be eliminated. So this is what we have. And this fraction is equal to capital Fs. So now we have to find the inverse. Just a reminder that this is coming from this function. So basically, I rewrite this f of s equal. Now I'll split this into two parts, two fractions, and we can go ahead and find the inverse of this. So now I'm gonna find the inverse Laplace transform of the left hand side and the right hand side. So finding the inverse, it will be in terms of t. Now the inverse of 1 over s minus 3, it will be e to 3t plus transform of this, I'll carry the 4 outside, so I'll have 4, then e to the t. Just a reminder that I just factor out the 4 and find the Laplace, the inverse Laplace of 1 over s minus 1. And that is what gives us e to the t. And that's it. So this is the solution of the differential equation using Laplace transform. Thanks for watching, guys. If you have questions, you can leave a comment below. Have a great day.